So let me just start the demo this morning. My colleagues will let anyone else in who comes in, so just let them in automatically. I want to say welcome. First of all, I think this is almost our first webinar ever, at least public webinar featuring the FoodSense Generation 4. So you may have seen videos about FoodSense Generation 4. I'm going to go a bit quick because I don't want to waste or burn up time. But let me just say that this is the first public demonstration of FoodSense Generation 4. I'll give you a little bit of a background on this. Anyone who adopts the FoodSense, you can expect to get personalized online training. If you watch any kind of videos on YouTube and stuff like that, you'll see that we have a fully functioning lab. Anyone who becomes a real customer of ours actually gets live demos and we help them in real time. We do weekly webinars. So if you've got any technical questions of ZP, there's a weekly webinar that runs 8 a.m. London time every Wednesday, but also that's recorded so you don't have to watch it live. And we also do monthly webinars and demos. So this is kind of this particular webinar is a special webinar specifically for really our clients and collaborators in India, and it's run with our very strong collaborators in India called Technando. But we do monthly webinars anyway, always on FoodSense. So just sort of know that. So just for example, even though this is a more sort of private restricted webinar specifically for India, we are doing one on the 26th of October, which is more of a public format. But this is a special kind of, I would say, first public demonstration, live streaming demonstration of FoodSense generation number 4. I will just give you a very quick introduction to ZP. I will talk fast. My name is Martin. I'm one of the co-founders of ZP. We launched in 2014. We are ISO 13485. I would say this is one of the highest quality standards you can have because this one is meant for human health. We are contract developers and manufacturers of electrochemical biosensors. Our facilities are quite large and we're primarily in Norway and the UK. And this is the team online this morning. I think there's more ZP people than anything else. So we've got Niti's online, Guyana's online, Solron's joined us, Aftab from Technando is here, Lynn is here, our data science expert, and myself as well, Martin Peacock. We do have multiple sites around the world. Around the world, around Norway and the UK, but we do have multiple locations in here. So on the just a quick one, on the 16th of October, so just about a week ago, we did go live with Generation 4 FoodSense. So today we're going to talk and demo live Generation 4 FoodSense. If you come in late, don't worry about it. We're recording this and we'll edit it and send you out a link later on. So FoodSense Generation 4 it's smaller, but it's elegant in so many more ways as well. It's easier to use, and you're going to see that ease of use come through today. Things like how we put the sensor in there, how we make the electrical connection, the way we can actually just clean it. It's more accurate. We've improved our algorithm that converts the raw signal into Scoville heat units, has been improved. This product is probably over 5 years old at this point. So this is Generation 4. Obviously by definition, we've had a G1, G2, G3, and now it's Generation 4. So it's all the time we've always learned our lessons and gone for a sort of a better product. Well, the nice thing about this product at this point is it's actually dramatically dropped in price. It's cloud enabled, and this means that when you see the guys do a demonstration today, you'll see the result appear on their phone. That's great. But what actually also the raw data is saved in the cloud. So if there's ever a discussion about precision, accuracy, how do you know that result is real? The reason we know the result is real is we can see the signal. So if you do like an HPLC test, you will get a test certificate, and in there it will say Scoville heat units, but you will get no real evidence that that's actually accurate. You won't see what's called the chromatogram. You won't get the calibration curve that HPLC used, or the HPLC operator used to convert the chromatogram or the peaks in the chromatogram to Scoville heat units. But with ZP, you get the raw data, so we can actually be very useful when we're helping clients understand, their results. It's also got a number of nice little features, that LED lights that tell you it's on, tell you it's working, tell you that that it's done the testing. Today we'll do chili and ginger. You'll see that by the use of QR codes, Guyana will be able to change from one assay to the next assay. So there is a quite a nice video online. I'm not going to talk you through it, but it does give you a quick sense of the team and really the facilities that have gone into this. This is a world-class, facility with, really excellent engineers and, and us, from really around the globe. And we've all brought all our brains together to create something that's really quite elegant and is almost like a nice, it's got a very nice experience when using it. This is something that will come up today. You will see that the guys can use QR codes and go from chili to ginger or from ginger to chili. So you will see that. And I want to say now that I've left out the slides, but the app is available for downloads also on the Play Store. So once you're a customer or client, then we'll direct you towards the app. As I say, if you've come in late today, don't worry about it. We're recording this anyway, and you'll be able to watch that. I'm not going to overplay this, but you'll see us today do a demonstration on ginger. So one of the analytes that the FoodSense Generation 4 can run is ginger, but it's actually the same meter every time. Same app, same meter, different sensor, different buffer. So the chemistry sides change depending on the analyte, but the hardware and technology actually stays the same. Also, I just want to put this out as well. Please contact us if there's other tests that you would like added to FoodSense Generation 4. What we're saying to you, especially you attendees today, is today we've got chili and ginger, and we're just looking for inspiration. Understand that even if you ask us for something, it could take a while for it to appear, but we are, open to hearing what you are interested in. And I've put a little, foodsensetechnology.com, contact us. So we would be interested in hearing what other people would like to test. So I won't influence you on that. Just say, if you've got something in mind, let us know about it. It's probably worth saying the history on this. It's a patented technology, and we have the patent license from Oxford University. If you're ever interested, there's an original paper by Professor Richard Compton. The molecule that we're detecting is capsaicin. This is the guy that essentially, binds to receptors and gives you the sensation of hotness. We are using, again, as part of the patented technology, cyclovoltammetry. Cyclovoltammetry has a very distinct fingerprint, so it's going to tell us that is capsaicin. And then you'll hear, if Solron's part of this meeting today, and Guyana, you'll hear them talk about area under curve is proportional to capsaicin. HPLC is the kind of, at the moment, I think, is the way that most people try to objectively measure this. There are a lot of problems with HPLC. Some people do testing, but this is not objective, it's subjective. And then there's obviously FoodSense. I realize we're on generation 4, that's generation 3, and I will get that image improved. So this is not a subjective test. Subjective tests are, you taste it, you give me an opinion. I've had people say to me, oh, no, it's hotter than that. And you're like, but really? I mean, how do you classify that? So I'm sorry, but, in this modern world, people really want evidence, of numbers, let's say. And so, this is an objective measurement, and you can get reports and the raw data to really prove this. We have validated against HPLC. ZP does own a Waters HPLC system. Just a side note, the first HPLC system on the market was actually from Waters, but obviously we've got a modern instrument. But we have checked our measurements versus the electrochemical measurement as well. I'm going to go a little bit quicker, but just to say, if you join late, don't worry, we're recording this anyway, and we'll send you a recording. But I need to go a little bit faster because of the time. I also want to say that it has academically been validated as well, independently of us. This is Charlie Rower at the University of Minnesota. If you see a link, the links will take you to those websites where actually his original paper sits as well. It's probably worth saying that HPLC is the thing that we're most sort of compared against. But it's interesting, if you send the same sample to 3 different labs, you will get 3 different results. So HPLC, I know you get certificates of analysis and you say, oh, well, there we are, that's the truth. You send the same sample to a different lab, you'll get a different result. So be careful with HPLC anyway, even though you're paying for it. You never get the raw signal, you never get the calibration curve, you just get a result. And there's never any error associated with that result. if you ever want to do this, and we do have billion-dollar customers that have done this kind of testing, where you send the same sample to the same lab on 3 different occasions with 3 different sample IDs, and they get 3 different results. So HPLC between labs is different. HPLC within the same lab is also different as well. So be a little bit careful with HPLC anyway. I'm going to slightly go technical, and then we're going to back out and do the demos, but I just want to say something about the solubility of capsaicin. So you will see that when we do demonstrations, we will often say, if it's mild, medium, or extra hot, let's say, we use different amounts of buffer to prepare the samples. So if it's mild, we do something a 10-fold dilution. If it's medium, we might do a 100-fold dilution. This is based on the fact that capsaicin is poorly soluble in the buffer, which is good because actually we could add organic solvents, but we don't want to add organic solvents because then it becomes a toxic liquid, which you've got to handle with care. The liquid that we do give you is very innocuous. Don't drink it, but if you did drink it, it would do you no harm, but don't drink it. But I'm just saying here that there's a scientific reason why we change the volume of buffer with the hotness of the product, and that's because capsaicin has a limited solubility in liquid or water samples. The reason you can get higher concentrations in sources is the oils and the fats help solubilize capsaicin, but capsaicin itself is actually quite poorly soluble. So I've written here that the solubility is 480 Scoville heat units. So that is the maximum solubility you can really get into the, I want to call it the aqueous phase, which means the water phase. This is an important number. Now, don't call it 480 Scoville heat units, just round it up to 500. So that's a mental number I'm going to keep in my head. Because what I want to say is, if you say to me, and we'll do this today, if you say to me, oh, well, I think my chillies or my chili powder or my chili sauce is 0 to 5,000 Scoville heat units, we'll say, oh, do a 10-fold dilution. Why? Because 5,000 divided by 10 is 500. So I know we're in our solubility range. If you say to me, oh, no, this is a chili powder. Actually, no, let's say a chili sauce, a hotter chili sauce, which can be 20,000 Scoville heat units. Then we would suggest maybe a 1 in or 100 dilution. Because, for example, if it was 50,000, 50,000 divided by 100 is 500 Scoville heat units. So you can see I'm mentally just doing this quick bit of arithmetic. If somebody said to me, oh, this is a really hot chili powder, and it's 500,000 Scoville heat units, which is, obviously 500,000 Scoville heat units, we may say do 1 in 1,000 dilution. Now, none of you are really going to have these kind of samples, but I just saw the other day that they've bred a new chili at 1-point-something million Scoville heat units. But if that is the case, then we're going to be doing a 1 in 10,000 dilution. But that's an extreme case. 95% of you are going to be below these Scoville heat units. But if you get stuck and you are a customer, don't worry. We do personalized support of our clients on this, even writing reports and SOPs. Just to say that people do ask us a lot about what's your accuracy or what's your precision. This is not my data. This is actually data. So somebody owns a FoodSense, and they were actually comparing it against the HPLC results. So they have the HPLC results. So this is clearly, to me, some sort of mild sauce. It's a bit hotter than Tabasco, but it's 6,358 Scoville heat units. They then measure it on the FoodSense. That means if you think the HPLC is the accurate one, that it has an error of 5%. But they did 15 samples, which is, really a lot of effort from them to run 15 samples by HPLC, which would have cost them about a lot of money to do that. But it was much lower cost for them to do the FoodSense. They did all that. And actually, the average error after all of this was 0%, which is nice because it wasn't our data; it was actually the client data. Now, I say here is we got a demo. So what I'm going to do is I'm going to turn off my mic, turn off my camera, and then my colleagues will come in from Norway and do you a couple of live demos regarding the FoodSense. Guys, and we have to go fairly quick because I've overspoken, but if you want to come on, that'd be great. Thanks very much.
Hi everyone, I'm Ganya. I'm an engineer here in Zimmer & Peacock, and I'm here with Soron. We'll do a demonstration of FoodSense G4. Now you can see our new device. If we compare to the previous one, the size-wise is almost the same, but we made major improvements to the design and also to the algorithm itself. As the first thing is that we introduced the cartridges. So right now, we don't need to handle with the sensors. We just need to handle the sensor with the cartridge. So the difference between two is that the cartridge has more space to hold. So we don't need to worry to touch the electrodes to not ruin them. And it's also much easier to insert inside the device. As you can see, for the previous version, it was hard to insert it. And it was also hard to align the sensor inside the opening. But right now, all I need to do is to insert the cartridge here and then click it to close. And then the sensor will be connected through the pins, as you can see here. We can also disassemble the device in case there is some spillage of the solution, and it's easy to clean, and then it goes back. It's just like this. It's again a really easy movement. Yeah, I'll just start the demonstration. Just connect the device to a USB-C cable. And once the device is connected, I can press the button for 2 seconds, and we will see the green light, which will indicate the device is on. And also, in front, we will see that LED bar is blinking blue, which means the device is ready to be connected to the mobile app. When it comes to the mobile app, we have the Sensitol mobile app, which is available for Android and iOS. So all we need to do, we need to scan the QR code. The QR codes are representing the sensors. Like for example, if you want to measure the chili, we need to scan the QR code of the chili. If you want to measure the ginger, then we need to scan the QR code for the ginger. I'll just quickly scan the chili QR code. Now the device is ready, and it also says the chili sensor and shows the sensor part number and also the batch ID. Now all we need to do is to connect the device. For that, I'll just press the Bluetooth icon on the top. Then the device will scan and find the available devices. And right now the device ID is Sensitol 1003, so I'll just click on it to connect. Now the device is connected, as you can see on the top, and also we can see the serial number of the device and also the MAC address. And now we can change the test settings. I'll just click to the card, and I can set the sample ID. I'll just write chili test. And also the cluster name. So the main advantages of the Sensitol Sensitol platform and the FoodSense G4 is that it's connected to the to Chilli, which is our data management and storage platform. And I can write the cluster name and in order to find the test data inside the Chilli. I'll just write demo here. And the operator ID is my email address because I logged into the app using my Chilli credentials. Now I'll just go to Assay, and the device is ready to be tested. So for us to test a chili sample, we need to prepare the sample. This is a already prepared sample with 1 parts of chili sample and 9 parts of our CP chili buffer. We want to use the buffer because we want to have the same environment for all the samples so that we reduce the variables, and also because we need electrolytes for our tests. So for this sample, I am using a dilution factor of 10, as you can see in the top region of the app. Here you can choose between different dilution ratios, but for this sample in particular, we have a dilution factor of 10. And the instructions for how to test is on the screen of the app, and it says to place and lock the cartridge, which we already did. And next step is to pipette 50 microliters of the sample onto the sensor. 50 microliters is a sufficient volume for pipetting, for covering all of the electrodes of the sensor. So when you pipette onto the sensor, be careful not to scratch the surface of the sensor, but just pipette it onto like that, and then I will click Start Measurements. And right now it's doing an electrochemical measurement called cyclic voltammetry, and it's varying the potential and detecting capsaicin, which is the pungency molecule in chilies. And it's running the analysis and also uploading the data to Chilli. So the results are coming back in molarities, ppm, and scald heat units, depending on your personal preference. The upload complete means that the data has been uploaded to Chilli and been analyzed, as we can see with the results coming back. And now my colleague Guyana will show you the results in Chilli. Yeah. So the first thing that I need to do is to log in my Chilli account. I'm using my email and passport and clicking the sign in button. It's a little bit slow. Yeah. Now I'll just search demos, because as you remember in the beginning of the test, I wrote demo as a cluster name. Then because the MAC address of the device, it was ending with 4C, I'll just click on it. And we see our test results, which says Chilli tests, which also I wrote it in the beginning of the test. All right, so here you can see the cyclic voltammogram of capsaicin. And when we go through the analysis of this assay in particular, you can see that it's looking at the reduction peak of the molecule, and it's running some calculations with an algorithm based on lots of results, and also giving back to us what the particular concentration for this sample in particular is based on that algorithm. And that,
so I just want to step in for a sec. I just want to step in for a second and say, I know you guys are going to do another demo on Ginger in a moment, but I think this is the only instrument out there that actually we give you a result on the phone. So you get the result, you know, just write it down, 1300 Scoville heat units, done. You know, that's your, but also we and you can see the raw signal. Now you don't need to look at this raw signal, but it's really important because you will get people say, how do you know it's right? When you look at these, you know, these are just silly squiggles, but it's cyclic voltammetry, and the shape tells us it's capsaicin. And it's really important to see, because somebody's asking, well, what about complex samples? No, we can see 1, 2, 3 peaks in there. That tells us it's capsaicin, and the area under these curves tells us how much capsaicin is there. And is literally, when you do your HPLC, you don't get the chromatogram and you don't get their calibration routine. So you really are trusting it, let's say. So it's important that we actually, you know, we can always troubleshoot or defend the data because we get the raw signal as well. You don't need to look at it, it's interpreted, but you do also have it as well. Sorry, go ahead, Solrun.
No worries. Yeah, so as Martin was saying, it's, yeah, the Chilli is for you to look in depth into your results. As for the results, will be provided to you through the app. So now we will run a quick demonstration on chilies. Yeah, but before that, I'll just show once the measurement is done, the LED bar is showing green, which means that measurement was succeed. So now when I press done, it will turn to white again, which means that the device is ready for the next measurement. Now we'll just scan the QR code again. As we are running a different assay, this time we're running a ginger assay, we need to scan the QR code in order to get the correct algorithms with the batch numbers of the sensors in question. So these are one-time use sensors because these organic molecules do like the surface of the sensors. So we dispose of the sensors and insert a new one for every measurement. So I just inserted a new sensor, a new cartridge, and now I will test this sample, which is a ginger sample. Again, it's a 1 to 10 mixture ratio, but I will first change the test settings just to say ginger. So you don't need to change these names and cluster IDs in the settings. It's just so that's easier for you to organize your data. It will be uploaded with dates and times, so you can figure it out. But just for the simplicity, we are changing the names. So again, a mixture ratio of 10, and I will apply 50 microliters onto the electrodes of the sensor, just like that. And then I will click Start Measurements, and it will run through a cyclical tomogram also for ginger, but using different settings, which is according to the assay scanned with the QR code. And it's looking, as Martin was mentioning, at the peak heights and the area below the peaks to assess the concentration in this sample in particular. So now the measurement is running to an end, and here you see that the ginger sample is being reported to you in molarity and grams per liter. And it also says upload complete. So again, we will have a look in the Julie report to look at our raw data. All I need to do is to refresh the screen, and then we will see the ginger test. We'll click on it, and here are the results. Here you can see the voltonogram, and yeah. And you can see that this assay is a bit different than the other ones. We are looking at different ranges, and it's a different molecule, so of course we need to apply different settings. So as you can see, it's easy and quick to run the samples, and the sample preparation itself is a crucial step, and also you need to determine what mixture ratio to use for your samples. If it's more spicy samples, you will use a higher concentration, and you will also maybe even let it rest on a bench just in order for it to extract from the sample into the buffer solution. But we do have some IFUs coming with the device itself to give you some guidelines to how to do this.
Great. So I do appreciate the amount of interaction that's actually gone on during the presentations today. I think what we're going to try and do is also I'm looking at the questions now, but I just want to say that we hold a weekly webinar at 8 a.m. London time on Wednesday. So I'm going to try and somehow capture all these questions and also cover them in the weekly webinar. Subscribe to our YouTube channel, because that will let you know when things are coming up. So I think I said I'm just looking at the questions now, so I will answer them. I did say at the beginning that if you're a client, you get personalized training anyway. But we do weekly webinars answering questions, and we also do monthly live streaming demos like we have today. Obviously, we've got a lot of faith in our system because we're able to turn up and do live demos. So I'm just going to read some of these questions. One of them is, excuse my cough. Somebody says here, look, I've got a 1 to 2% chili powder, probably then mixed in with other 1 to 2% is quite a lot actually. So that means you will have quite a strong signal. So I don't have a problem with the 1 to 2% chili powder, because 1 to 2% in, some people think by mass that sounds quite not a lot, but actually chili powder is quite strong in capsaicin, so we should get a nice strong signal out of that. The other one is this AOAC approved. So I forget the AOAC, but I know the method and I know the organization, and they do have an HPLC version. The quick answer is it's not AOAC approved at this moment, because it's they're a large organization. It would take them quite a while to approve these things. What we have done is we run the AOAC method ourselves on our HPLC systems. So we run that method and then we verify against it. It's also probably worth saying that when Charlie Rower at the University of Minnesota did his testing, he would have sent it and they would have run an AOAC method, HPLC method there as well. And also I did put some data up earlier on during this presentation where actually that was also AOAC method as well. So the validation that we have done, our internal validation, it's also been academically validated, but it's not AOAC approved. But I do understand the question. Of course, with AOAC, you need a HPLC instrument. It's about $50,000, etc. Where this is sort of a fraction of that cost. I would also say, if you're interested, there is another repeat of this webinar. So if, let's say, you want to see this again and just rethink it through a bit, there is a webinar on the 26th of October. But otherwise, I have seen the questions. AOAC, it's not AOAC validated. 1 to 2% chili powder loading, that's fine. If it's a complex sample, you've seen us run some complex samples today. And we're able to see the capsaicin quite nicely there. And people were wondering about what this sensor is for measuring capsaicin. So people were saying, well, what about spiciness in general? Well, we can measure ginger, which is gingerol, and we can measure chili, which is capsaicin. If you have any other ideas, then there is a contact us on the FoodSense website. We'd be interested in hearing that. So I think, Niti and Aftab, I think that's us for this week. I just want to say, or not this month, I would say. If you've got any questions, reach out to Technando. Maybe you're in contact with Niti, or reach out to us on the FoodSense Technologies webpage. Otherwise, we've gone 3 minutes over, but I hope the live streaming demo and the fact that we can get you the real raw signal as opposed to just a number and a certificate is useful to you. But from us, I think that's it. And I want to say thank you very much to the guys in Norway. Thank you very much to Technando, and thank you very much for Niti for organizing this today. Okay, thank you so much.